Hello everyone, welcome to the signal system class. In this video, we will find out the jet transform of shifted unit impulse, that is delta t minus nt. This is a shifted unit impulse function. We have to find out the jet transform of this function. So we find here that the function ft is equal to delta t minus nt, which is a shifted unit impulse, and we have to find out the jet transform of this function. So first we will prove that the sampled output f star t is equal to ft, that is we will prove that f star t is equal to ft is equal to delta t minus nt. Now from a chapter on jet transform, we found out that whenever a continuous signal ft is fed to a sampler, then we get a sampled output which is denoted by f star t, which is a discrete sampled function, and this f star t can be written as ft into delta t, where delta t represents a periodic train of unit impulses which are spaced t seconds apart. This is a periodic train of unit impulses which are at a distance of t seconds apart from each other, and the magnitude of each of these impulses unity. Now we can write this delta t as summation of delta t minus nt when the value of n varies from minus infinity to plus infinity. So we will get this same graph. Now this star, which is a superscript used in this f star t, is used to indicate that this function is a discrete sample function, because we find out the jet transform of only a discrete sampled function. So we find that f star t is given by ft into delta tt. Now the value of ft is delta t minus nt, so we have substituted the value of delta t minus nt in this equation. So we get f star t is equal to delta t minus nt into delta t. Now from here we find that delta t is equal to delta t minus nt. So we will get the value of f star t as delta t minus nt into delta t minus nt. So delta t minus nt into delta t minus nt is the same as delta t minus nt. And what is delta t minus nt? This is ft, which we found out here. So we have proved that f star t is equal to ft is equal to delta t minus nt. We have proved this. Now we will find out the jet transform of this function. So jet transform of the function is written as fz. So this will be equal to Laplace transform of f star t when we substitute the value of est is equal to z. Now we know that the Laplace transform of f star t, that is delta t minus nt, when e to the power st is z. So this will come out to be e to the power minus nts when the value of est will be equal to z. So we can write this as e to the power st to the power minus n when e to the power st is z, and when we substitute this value in this equation, then we get this will be equal to z to the power minus n. So we find that the jet transform of the given function, that is shifted unit impulse, will be equal to z to the power minus n. And from this we also conclude that if we want to find out the jet transform of the impulse function, then this can be written as jet transform of delta t minus nt when the value of n is 0. That is, if we substitute the value of n is equal to 0, we will get the same function delta t. And because we derived here that the jet transform of the shifted unit impulse is z to the power minus n, so this will come out to be z to the power minus n when we will substitute the value of n is equal to 0. So if we substitute n is equal to 0, this will come out to be 1. So we have derived that the jet transform of the unit impulse is equal to 1, which we have also seen in the previous presentation. So in this way we can find out the jet transform of shifted unit impulse and the jet transform of a unit impulse function. So that's all in this presentation. See you in the next presentation.